Okay, this lesson is on the topic of the ratio test. You're like, oh, more tests? This, I believe, will be the last one you really do need to know. And this test is useful when you have series that involve factorials, the exclamation mark, or exponentials. Because the idea here is you're going to compare the terms in a ratio. So the ratio test says the following. If you've got a series, it will converge if the limit as n approach to infinity of the absolute value of the comparison of the two terms. So a sub n plus 1 is the, next term. A sub n would be like the current term. So the two terms beside each other, if that ratio is less than 1, this converges. Of course, if it's greater than 1, then it diverges, because then you can see that the ratio of the terms get bigger and bigger and bigger. Similarly, if it's equal to infinity, it definitely diverges. And the only hiccup with this test is that the test is actually inconclusive if the ratio equals to 1. So if the current and the next term, when I do the ratio equals to 1, we really can't say it's convergent or divergent. We just don't know. All right? So let's take a look at a few examples here. I'm going to ask you to please determine the convergence or divergence of the following series. Let's use the ratio test. I would use this because I see a factorial. Yay! So I would be saying to myself, let's take the limit as n approach to infinity of the absolute value of, now the nth plus 1 term really just says wherever I see n, replace it with n plus 1. So it's n plus 1 factorial. Divide by 3 to the power of n plus 1. And we'll divide that by a sub n, which is just n factorial over 3 to the power n. How many of you hate writing these complex fractions because you're like, I'm wasting so much space? So yeah, I'm like that too. So I'd rather just rewrite this as the absolute value of n plus 1 factorial over 3 to the power n plus 1 times the reciprocal, so 3 to the power n, n factorial, like that. Now, let's see how we can simplify. I've got 3 to the power of n on the top and 3 to the power n plus 1 on the bottom. So I hope you can realize that this just simplifies to a factor of 3 in the bottom, or the denominator. How about this n plus 1 factorial and n factorial? Don't know if you remember, I hope you do, but the idea of the n plus 1 factorial is that it's just equal to n plus 1 times n minus 1 times n minus 2, and so on. And the n minus 1, n minus 2, this is just the same thing as n factorial. So notice then, if n plus 1 factorial is just n plus 1 times n factorial, the n factorials then divide out, and you're just left with a factor of n plus 1. So we can continue to do this. I now know that if I take the limit of n plus 1 factorial of the absolute value, it's really the same thing as the not absolute value. This, of course, equals to infinity. And then I'll say, by the ratio test, since the limit of n approach to infinity of the absolute value of the comparison of the two ratios is bigger than 1, this series diverges. And there we go. Okay. Once again, officially in the AP exam, you should be listing all the criteria like this to justify the case. I will, from now on, just be a little bit cheeky and just be a little bit simplified and write down just if it converges or diverges by the ratio test, or whatever test I also use. Okay? Now, some of you are thinking, hey, couldn't I have done this question using the nth term test? Yeah, this would have also worked, okay, for this particular one. The nth term test, remember from Unit 7? This is also okay. If you want to try that as an exercise, I leave that to you. All right, numero 2. So the limit of n approach to infinity once again. Notice why I'm using the ratio test here. Powers. Can I not write it as division? Just save myself a step. So 3 to the power of now n plus 1, because I have to add 1 to it. It's the next term. 4 to the power of n plus 1, n plus 1 all squared. And once again, I'm supposed to divide by the term, but to save some space, I'm just going to say let's multiply by the reciprocal. And I just have to then reciprocate what we have written over here. That's just the following. Okay, I guess I don't need to worry about any of the negatives because there are no negatives here. So now it's just how do we simplify terms? Let's take a look at the base 3 values first. And n plus 2 in the top and n plus 1 in the bottom. Base is the same, so we subtract the exponents, n plus 2 minus n minus 1. That, I believe, just gives us 3. I can do the same thing now with the 4 to the power n and 4 to the power n plus 1. I believe that leaves us with a 4 in the denominator. N squared and n plus 1 squared we can't cancel out, so we'll just leave as this. But remember, I'm taking the limit to infinity, so by the end behavior model, I can just say I only need to look at the largest power in both the numerator and the denominator. This simplifies to 3/4. That's definitely less than 1, so therefore by the ratio test, and I'll call this the RT, we know the series converges. Okay. Moving on to number 3. Negative 1 to the power of n. There's where my absolute value will come in quite handy, because now I really don't need to have the negative 1 to the power n affect my calculations. I guess I could put the absolute value there, but like I said, we know that if I just ignore that and use this part, I'll be fine. So if I were to use the ratio test, it's the nth plus 1 root all over n plus 1 minus 1, which is just n. We're going to divide that or multiply it by the reciprocal, which is just n minus 1 over root n. Like I said, you could have, you don't need to, you could have written the negative 1 to the power n in front and then the absolute value, but that just negates that negative 1 to the power n anyways. So I'll just keep it as what I had before. And now we need to simplify this expression. I don't know if I can actually, right? I guess I could. What does that simplify to? Well, if you think about the n behavior model, you'll have root n times n on the top and n times root n on the bottom. So by the n behavior model, you'll also get here that this equals to 1. And so by the ratio test, it is inconclusive. Ratio test, inconclusive. So therefore, do we just leave the answer like that? No, because you told me nothing. You gotta tell me if it's convergent or divergent. So, hello, hello, hello. Let's try another test. Which other tests do you think would be good? Any ideas? You have a negative 1 to the power of n. How about consider using the alternating series test? Yeah, from Unit 7. Gotta use those things too, remember? And I will ask you to just quickly do this for me then. Remember the alternating series test like this. If I were to plug in infinity, I think you would get 0. Okay. Note also that I should have also said that root n over n minus 1 is decreasing always. So therefore, by the alternating series test, we know this converges. Okie dokie. All right. Okay. Any questions? You should save them for me in class. Take a look at number 4. The summation of n equals to 1 to infinity of 2n plus 1 factorial. Whoa! What does that mean? Divide by 3 to the power n times 2n minus 1, and then multiply by n factorial. So what I've showed you here when you have a factorial is that we're not looking at multiplying by all the whole numbers before that term, but we're just looking at in this case, the odd numbers. Notice 2n plus 1, then 2n minus 1, 2n minus 3, and so on. Okay? So that hopefully will give you an idea of what that double factorial means. Now let's go ahead and try to figure out if this converges or diverges. Here we go. The limit of n approach to infinity of 2n, and this would be n plus 1, right? So I really should put 2 bracket n plus 1 like this, plus 1. Double factorial. Divided by 3 to the power n plus 1. 2 times n plus 1 minus 1 times n plus 1 factorial. We are dividing by the current term, which is the same as multiplying by its reciprocal, so I'll put 2n plus 1 factorial on the bottom, 3 to the power of n on the top, 2n minus 1, and n factorial all in the numerator. And now it's time to simplify. Maybe what I will do, so that you can see what's going on, is I'm going to expand this out first, and then most likely when we do the ratio test there will be some sort of simplifications. The top will then become 2n plus 2 plus 1 is 3, so 2n plus 3 factorial all over 3 to the power n plus 1, 2n, that's plus 2 minus 1, so that's just plus 1, with another n plus 1 factorial. Copy down the second one again, 3 to the power n, 2n minus 1, n factorial, 2n plus 1 factorial. Okay, let's deal with that factorial first. Remember, these are all the odd numbers. And notice that 2n plus 1 factorial is really just this, so 2n plus 3 factorial is just that with an extra factor of 2n plus 3. So notice the numerator and denominator have common factors of 2n plus 1, 2n minus 1, 2n minus 3, and so on, so those cancel out. So with the green terms here, all you're left with is the limit as n approach to infinity, and you have just 2n plus 3. Okay. How about the 3 to the power n, 3 by n plus 1? That leaves us with just a factor of 3 in the denominator. The n plus 1 factorial and the n factorial here, that simplifies to just an n plus 1 factor in the denominator. And we still have our 2n minus 1, and we also have a 2n plus 1. So that's what we've simplified things to. That's not bad. I want the limit as n approaches to infinity in behavior model. 2n times 2n, of course, is 4n squared on the top. Now 3 times 2n is 6n times n is 6n squared. This just becomes 4 6, which is definitely less than 1. So therefore, by the ratio test, guess what? This converges. Okay, so as promised, this is the last test for convergence and divergence. And now you need to think about the following. It's been easy doing them when they are in different sections, but what happens if I were to combine them all together? I don't tell you what section they're from. I just say, hey, does this converge or diverge? And it's your job to figure out how to figure out which test to use. So here's a little recipe card you can use and help you figure things out. I always ask myself this: does the nth term approach 0? Okay. If not, the series diverges. So I always try to use the nth term test first. Okay. Then I ask myself, is it a special type? Is it geometric? Then, of course, remember, you have the ratio being less than 1. Is it a P series? Remember that, we just did the other day. And is it alternating? That's from Unit 7. So I ask myself those types, because if it is, I can identify those types. Easy, just use those tests. Then I look and say, if all those don't work, I ask myself, can the function be integrated? If yes, it's the integral test. Is there factorials or exponentials involved? Then use what I just showed you, the ratio test. And then I look at, can I use or compare it to a special type? So compare larger or smaller series. That's the direct comparison test. Or the limit comparison test when you really have some messy algebra. So it's your turn now. Okay, I've listed the test here on the next page. You should have these all memorized. I've listed the order I would do things as well. Okay, and now I'd like you to quickly review these yourself and try these mixed examples. 6 mixed examples for you to work on to figure out if it's convergent or divergent. And once again, please tell me what test you used. All right, so I'm done teaching. It's your turn to do some quick review and to try to attempt these 6 questions. Have fun, everybody. I'll see you in a few minutes with the answers. Easy thing like this, I would definitely use an integral, especially when I see that substitution rule probably needs to be done. U sub, by the way, I'll say E. I'll just say x cubed, I guess. It's actually negative x cubed. Get a negative 1/3 in front. E Screen that, you still get negative 1/3 e to the negative x cubed, and now you're evaluating this from 1 to b. Once again, the limit as b approaches to infinity is still there. Negative 1/3. This will be. I guess I could put 1 over e to the negative infinity. Minus 1 over 3e. Sorry, 1 over e. 1 to the power of 1 is just that. Simplify, that's 0, so that's positive 1 over 3. So since this is a number, series converges by the integral test. This one you see powers, but I see this as a special type of power. The ratio is just e over 3. That of course is less than 1, so by the geometric series test, this series converges number 8, 9, and 10. I suggest that you compare this one to the sum of 1 over n. This is the harmonic series, or the p series, where p equals to 1, so therefore it diverges. I can ask yourself now, after this diverges, let's do some comparisons. Which is really the same thing as multiplying. So n over 4n plus 5. Using n behavior model, this just becomes 1/4. And so what do we know? This is finite. This is positive. So therefore, the original series must also diverge by the limit comparison test. The original series also diverges. Enough. This negative 1 is always a hint. Alternating series test is what I should be using. I know that the terms always decrease in absolute value. You can do that by taking the derivative, right, and checking that. I know 3 over n squared, all the terms decrease. I can then take the limit as n approach to infinity of 3 over n squared, and that, of course, equals 0. So therefore, that's great. This equals to 0. The terms decrease in absolute value. By the alternate series test, this series converges. And the last one here, whoa. I don't give you the summation notation, but I hope you can see the pattern. If you wrote down the sum of n equals to 1 to infinity of n factorial over 10 to the power n, you are correct. And this is a classic example of factorials and exponentials. How about using the ratio test? So the n plus 1 term divided by that or multiplied by the reciprocal, then you get the following. it, and approach to infinity, and plus 1 on the top, a factor of 10 on the bottom. This seems to equal infinity, so by the ratio test, this diverges. Woo! Your head going for a spin yet? You'll do more of that in class. See you then.